book that they left on my desk.
Oh, thank you. Okay. On page 32, in the electricity unit, we are going to be talking a lot about charge, okay? And we already know a lot of things about charge. But in the electricity unit, we are mostly talking about electrons. We're not usually talking about ions, although if you go into chemistry and you start looking at electricity in chemistry 12, you will be talking about ions. But grade 9 electricity, all about the electrons. How big are electrons? Do you remember? They are super, super small. And so can you imagine trying to count them? 1 electron, 2 electrons, 3 electrons. Are you going to get very far? No. So we're not going to be counting them one by one. Now, also in the electricity unit, what we are very likely to do is to compare the flow of electrons to the flow of water. Because, Jaden, could you close the door for us, please? It's a little noisy in the hallway. Thank you. Thank you so much. We're on page 32. Because we can all visualize the flow of water. Yes, we've all seen rivers, or if we haven't seen rivers, we've seen, like, you know, the little ditch beside the road and the water's going down it. We know what that looks like, but it's really hard to visualize the flow of electrons. So what we're going to do for this unit to make it a little bit easier to visualize, if we were looking at an amount of water, we might say, I have 1 bucket of water, or I have 2 buckets of water, or I have 100 buckets of water, whatever it is. So instead of counting individual electrons, we're going to measure buckets of electrons in big quotes, okay? So basically what we've got is we've got a container full of electrons, and each bucket of electrons contains 6.24 times 10 to the 18. That is 6.24 quintillion electrons. Let's write that out in standard notation. If you're interested in that, that's going to look like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm going to make that one not look like a P. There we go. 1, 2, 3, comma, 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 1, 2, 3, comma. That's how many electrons are in a bucket. Okay? It's a lot. But we're not going to call it a bucket because that doesn't sound very scientific. We are going to call this number a coulomb. So the last part of the word is like comb, except for it's loam. Coulomb. Coulomb. And that's because a French scientist did a lot of work with charges and electricity, and his name was Coulomb. That was his last name. And we can abbreviate Coulomb. This is the unit.
Did you get my test from the source?
I don't think so.
Okay.
Yeah.
So I finished it today. So
okay.
If you don't get it by 4 o'clock, I'll bring it up.
Okay, sounds good. All right, so we have the coulomb, okay, and the coulomb is a unit. Okay, it is the unit for the quantity charge. So in other words, charge is measured in coulombs. Just like distance is measured in meters, volume is measured in liters. And the abbreviation for Coulomb, very fortunately, is very easy. It is the letter C. It is a capital C, which is very nice. Now, charge is not a capital C, and it's less convenient. Charge, the abbreviation is Q. And you might think to yourself, why Q? Q has nothing to do with charge. It actually stands for the quantity of charge, and we have that actually on the next page, so we're not going to try and cram it on here. Okay. So a coulomb is a bucket of electrons. It is a unit for measuring charge. And a coulomb is just a really big number of electrons. And we're going to pretend that we can fit all those electrons into one bucket. And that one bucket we're going to call a coulomb. So here we have our quantity is the charge, which is abbreviated Q. And it is measured in the unit of coulombs, which is abbreviated C. And here's where I promised we would come across this. Q stands for the quantity of charge. Q stands for the quantity of charge. So that's where the Q comes from. So if you have trouble remembering it, you can look it up there. Now, if you're like, I'm still going to have problems remembering that, pull out your purple sheet. Everyone, pull out your purple sheet. And if you don't have a purple sheet, come and see me. I'll get you another one. Mm-hmm. Right there. So what you can see here is on the very front page, we have the quantity of charge, and the symbol is Q. The unit is coulombs, and the abbreviation for the unit is C. So this shows up on this page. It shows up on the second page as well. And then it also shows up on the very last page. But in the last page, we just show the Q and the C. So if you start to get them down and you just want like a pared back, simplified table, you can use the back page. But if you want all the information, use the front page. Back page, simplified. Front page has everything. Yes? Okay. And now we're going to talk about current. Have you guys experienced any kind of current? What kind of current? Pardon me? Wind? Yeah, you can have the wind blowing in a current. What things do we often refer to as having a current? Yes. Like in water, a river has a current. Yes? Current in water measures how fast the Tell your partner. What does current measure when we're talking about, say, a river? Tell your partner. So in water, current is how fast the water flows. So in other words, it is a rate of flow. So current is the rate of flow. And here we have a little picture. So basically, the speed of the water is the current. Now, let's say we wanted to actually measure the current of a river. How fast is it flowing? I actually think this would be a pretty tricky thing to do. You'd have to be pretty clever about it, but we're going to simplify things because we're in grade 9, right? One way we could measure the current would be in buckets of water per second. How many buckets of water pass a point in 1 second? Does that make sense? How many buckets of water would flow past one point in 1 second? That would be the current. So in electricity, we're not measuring the flow of water. We are measuring the flow of, guess what? Charge. We are measuring the flow of charge, and the flow of charge is electrical current. Current is another quantity. And wouldn't it be lovely if it were abbreviated C for current? But it's not. It's abbreviated I. Which you may be like, what? Why I? That's crazier than Q for charge. It actually stands for the intensity of the current. And don't worry, this again is on the next page, so you don't have to write that down right now. It stands for the intensity of the current. So that's our quantity. And a quantity must have a unit. Anyone taking like electronics or anything and know what current is, what unit current is measured in? And it's okay if you don't. It's all good. It's what we're here to learn. So it's kind of good if you don't. We'll just learn it now. Current, our quantity, current, which I remember I said is abbreviated I, as irrational as that may seem. Okay, as strange as that may seem, current is abbreviated I. And it is measured in the unit. Most often we refer to it as amps, which is abbreviated. Oh, thank goodness this one makes sense. Amps is abbreviated A. Amp is actually already an abbreviation. It is short for amperes or amperes. Once again, there was a French guy doing work with electricity, and his name was Ampere. Okay, so Monsieur Ampere and Monsieur Coulomb, they were doing the experiments with the electricity, and then they got these units named after them, the Coulomb, and the Ampere. Okay, I'm sorry for that atrocious French accent. I apologize to anyone whose native language is French. That was awful. Anyway, there we go. So current, I, is the rate of flow of electrical charge. And remember the abbreviation for charge is Q. The abbreviation for charge is Q because remember that stands for quantity of charge. And so the charge is measured in coulombs, right? And coulombs has a sensible abbreviation. Coulombs is abbreviated C. So the units have good abbreviations. Coulombs, C. Amperes, A. The quantities have weird abbreviations. Charge is Q. And current is I. Let's try that again, because you know, the more we say it, the more we'll remember it. On this side, we're going to say charge is Q. Over here, current is over here, current is current is I. Over here, charge is Q. All right. Just hopefully that'll help you remember it. We might do that again next day, just to make it stick in your head. So here's our little river analogy. If we are measuring the current in a river, the blue liquid, it's copper. Oh, look, it's CuCl2. Can you tell me the name of that compound?
It's copper chloride.
Copper chloride. What kind of copper? Copper what chloride? CuCl2. Copper what chloride? No, copper is extremely toxic. It kills things. CuCl2. Chloride has a charge of negative.
Oh, the charge?
Yeah.
Chloride has a charge of negative.
There's -2 for the two chlorides together. So what's the charge of copper?
Oh, it's 2. 4.
Hold on. Each chloride is -1, yes?
Oh, it's 2.
Chloride, chloride. And then we have copper +2. So this would be copper, Roman numeral, 2, chloride. So now you can start to read all these weird things that occasionally appear on my desk.
What's that do?
What does it do? We were reacting it. We actually started out with some of that this morning, and I put some aluminum foil in it. Does it look anything like aluminum foil? And there's a little aluminum foil left. But we put this copper 2 chloride in there, and it turned the copper 2+ into elemental copper 0, and it turned the aluminum, the solid aluminum 0, into aluminum ions, which then dissolve in the water. So the aluminum foil falls apart, and we end up with little bits of copper, which kind of look like rust at this point. There you go. Chemistry 12. Is this reacting? It's finally going. That's kind of exciting. Okay.
What's it used for?
All right, where'd I put my pen? Uh-oh. Uh-oh. Oh, this could be a problem. Sort of, maybe. Oh, well, that's okay. I got extras. Hopefully these work.
Okay, where, bro?
Hi. Yeah? Oh, right where? Oh, right there. Thank you. Okay, so current in a river. We would measure how much water passes a point in a second. So it's the water per second, yes? Water per second. That's the current of water. Now, if we're doing current in electricity, that would be like electrons flowing in a wire. And what's the symbol for current? I. So when we have current in electricity, we wouldn't be measuring how much water per second. We would be measuring how much
Intensity.
charge per second. Because it's how much charge passes a point in a second.
No offense.
So if we have our water, it's water per second, but what could we measure water in? It's not just any old water. We might say liters of water. We might say cubic meters of water. Or we might say buckets of water per second. Okay? And so for electricity, do you remember? We have this imaginary bucket of electrons. So we're going to measure how much charge, because the electrons represent the charge, how many buckets of electrons per second. And what did we call a bucket of electrons? A coulomb. 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 Everyone say it with me. Coulomb. 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 It's like Sesame Street here. So we are measuring it in coulombs per second, which is also coulombs per second. So the unit of current is a coulomb per second. Are you on your phone, Maya? No, I'm not on my phone. No, not me. I have very funny hands. Sorry. It's been a long week, and it's not even Friday yet. Getting a little goofy here. Okay. Now, take a look at this. This is our unit of current. But what did I say before that the unit of current was? The unit of current is the amp. So what that means is if the unit of current is an amp, and the unit of current is also a coulomb per second, what that means is that amps and coulombs per second are the same thing. Amp is a unit of current. And what's the symbol for current? I. And a coulomb per second is a unit of I current. So if we imagine this is our little checkpoint, and imagine we have a conveyor belt. Yes? And on that conveyor belt, we have buckets of electrons. What's a bucket of electrons? A coulomb. You'll get it. You'll get it. Just go home, practice a little bit. It'll come. Now, there's somebody standing beside this conveyor belt, and every time a bucket of electrons go by, they count. 1, 2, 3, 4 buckets of electrons. And if that took place in 1 second, like let's say that you were really good at counting and you could count like 1, 2, 3, 4, that happened in 1 second, that would be 4 coulombs per second. Okay? Or you could say, I'm going to start my timing when the clock reaches 20, when the second hand reaches 20. 1, 2, 3, 4, 5, 6, 7, 8. If 8 buckets of electrons passed in 10 seconds, so if we had 8 buckets of electrons, so in other words, 8 coulombs went by in 10 seconds, what would the current be?
I want to guess. I'm going to go with my gut. I'm going to say 8.
8? It's not a bad guess. Current is the buckets of electrons in 1 second. So if we have 8 coulombs in 10 seconds, that's the same as saying we have 8 buckets of electrons in 10 seconds. How many buckets of electrons would we have in 1 second? 0.8. And if we have 0.8 buckets of electrons in 1 second, that is 0.8 coulombs in 1 second. That's 0.8 coulombs per second. Which is the same as 0.8 amps. Because an amp and a coulomb per second are the same. And that would be measuring the current. And we're going to formalize this, and we're going to use guess cubs to like plug everything in to the formula. Okay, and you're going to have a formula for this, but that's just giving you an idea of the fact that you can sort of think these things through, and you don't always have to just rely on a formula. Okay?
I mean, with the music that
Okay, so amps are the same as coulombs per second. Next page. Current I, remember I promised we would write this down at some point. I is short for the intensity of the current. And guess what we have? We have a formula. And what did we do up here? We had the, what was on the top? What's on the top here?
That is, I will say Coulomb.
Coulomb. Coulomb.
Oh, Coulomb, same thing.
That is a coulomb. On the top are coulombs. What's on the bottom?
Second.
Seconds. What do coulombs measure? Coulombs measure what quantity? Coulombs measure,
The buckets.
they're buckets of electrons. What are buckets of electrons measuring? The amount of
Current.
charge. So coulombs measure charge. What do seconds measure? Seconds measure time.
I gotta do that. One second.
So in our formula, we're going to have coulombs is measured in charge. We're going to have charge on the top, and seconds measures time. So we're going to have time on the bottom because seconds are on the bottom. So our formula is going to be charge over time. So current is equal to charge over time. And we actually have that on the next page if you're worried about it being unclear from what's written here. Okay, we go here and we look and we say, here is my formula. In other words, it is the equation. Remember, the formula can also be known as an equation. And why would I call it an equation rather than the formula? Because it works really well when I use G-U-E-S-S, cubs. Guess cubs. That's the E is for equation. Must you memorize this equation or will it be on the data sheet? It will be on the data sheet. Now, should you choose, you can memorize it. And here's how I remember it. I quit. I quit. See the I? Quit. Quit. Q is over T. So if you're interested in memorizing it, that's one way you can do it. I quit. And if you do it with the hand actions, it helps you remember that I is on the top, Q is on the top, and then T is on the bottom. But like I said, do you have to memorize it? No, because it is on the data sheet. So we now know the quantity. Quantity is current, symbol is I. Abbreviation for the unit is amperes or coulombs per second. And we have amperes or coulombs per second. Charge, Q, is measured in
No.
coulombs, C. And time, T, is measured in seconds, S.
Our money Snapchat.
And one thing I'm going to draw your attention to is this little number 1 up here. Do you see that number 1? I'm going to circle it in red as well. And there is also a number 2. So we have a quantity and a unit. 1 is the quantity, 2 is the unit. And remember from last day, we're going to use quantity is equal to number and then unit. I don't think I filled this out very well. I think I want to change this a little bit. It looks like you're supposed to fill in that blank, but really what we're going to do is we're going to say, in this question, we have some given information. We're going to look for our numbers. What numbers do you see? Or sorry, in the question here, in the example.
Well,
We have 12 coulombs. Is coulombs a quantity or is coulombs a unit? Unit. What is the associated quantity?
Sean.
Quantity is charge, yes. So what we're going to want to do, and how do we abbreviate charge?
Like you.
Q. Okay. So what we're going to do is we're going to say our quantity, in this case, our quantity is charge. So that's going to be Q. We are given Q. And we know that Q is equal to a certain number of units. How many and what type of unit? There are 12, and the unit is
Oh, no, thank you.
coulombs. I'll say it for you. And what is the abbreviation for coulomb?
That's a
I.
That's a C.
That's it.
Okay, so coulombs are C. So we are given charge, and if it helps you out at this point, you can write that that's the charge. Okay, but eventually you'll want to just use Q because it's much simpler and faster. And what is our other number that is given in the sample question here? We have 4 seconds. Is seconds a quantity or is seconds a unit? It is a unit. What is the quantity? Time. So what we're going to do is we're going to write our quantity, which in this case is time, but we abbreviate time as lowercase t. So time is equal to is equal to 4 seconds. And I'm just going to write in black what these things are standing for if you're going to forget them. So C stands for coulombs. S stands for seconds. Normally, you would not write those down. You would get used to knowing what they are for, okay? So those are our given quantities. That's the G in guess cubs. What comes next in guess? G and then U. U is unknown. What is the unknown in this question? It says, what is the current? What is the current? Now, is current a unit or is current a quantity? Quantity. Current is a quantity. And what is the symbol for current? I. So what we're going to do is over here where we have our unknown, we're going to write our current I. Again, we're going to write quantity equals, oh, pen just went wacky. Sometimes it just stops working. I just have to plug it in and then unplug it again, and it seems to work. Very strange. That's okay. Current is equal to, do we know how many? Do we know the number? No, we don't, because it's our unknown. And then we can put in our unit if we know it. If we don't know the unit, we can leave it blank. So we don't know how many. Do we know the unit for current? Yeah, the unit for current is amps. Again, I'm going to write in I is current. A stands for amps. Guess. What comes after you? Unknown. Guess. G-U-E. What does E stand for? Equation. And you're going to say, I've got me some Q and some T and some I. I need a formula that relates Q and T and I. Do we have such a formula? Yes. What is the equation that relates Q and T and I? I quit. I equals Q over T. What's the first S in guess? Solve. And what that means is we want to get our unknown on the top by itself and on the left. Is our unknown I, is it on the top? Yes, it is on the top. Is it by itself? Is there any other variable with it or no? There's nothing else with it. It is by itself. Is it on the left? Yes. Okay, so this is done. We don't have to solve it. It's already in the correct form. Okay. The second S stands for, that's our third S. The second S stands for substitute. We're going to substitute the givens into the equation. So we're going to take I is equal to Q over T. We're going to rewrite it down here so we have room. And then instead of writing Q, we're going to write whatever the value and unit for Q are. What are the value and unit for Q? We've got charge. So that would be how much? 12. And we also have to include the unit. So 12, what's the unit for 12? Coulombs. Now we want to plug in the time. How much time? 4 seconds. Okay. So that was substitute. So that's the guess all done. And now we're going to CUBS, Cubs. We're going to calculate. What do you do when you calculate? This is easy. You just find the number, okay? If you can do it in your head, that's great. If you can't, you use a calculator, okay? Do you all have a calculator? Okay, make sure you're bringing it these days, okay? Because we'll be using it up until Christmas, okay? So 12 divided by 4, how much is that? 3. And then after we've calculated, what do we need? We need our unit. What is our unit? And we look here and we say it is coulombs per second. Now, you can leave it like that, and that's a perfectly good answer. However, it would be even better if we changed coulombs per second into amps. So we're going to write A for amps. But if you leave it as coulombs per second, that's okay too. No worries. So we've got our number, we've got our unit. What do we do next? We put a box around it. And then we stop at either 2 to 4 digits, but this one is a whole number, so I think we could just go with 1. Yes? Or we do the correct sig figs. And if you're interested in the sig figs, thank you. If you're interested in the correct sig figs, we have the number 12 and we have the number 4. How many sig figs in 12? 2 sig figs. How many sig figs in 4? 1 sig fig. So how many sig figs should our answer have? 1 sig fig, which is what we actually have here, so we're good. Okay. Oh, I was supposed to ask, is there anyone in here, and it seems unlikely because you guys are grade 9s and most grade 10s do not take AP courses, but there's the occasional person who's like accelerated in math or something. They're doing a survey for people who are signing up for AP courses next year. Is there anyone who is doing that and needs the QR code? That's what I thought. Okay, you might be. Okay, you know what? I'll send you the code. You can do the survey. Okay, yeah, I'll put you on my list. I've got a few here and there. Like I said, it's very unusual. Yes. The QR code as well, yeah. I think it's asking you what you're signing up for next year. So if you're not planning on signing up for an AP course, then you can if you look at it and you're like, I'm not signing up for AP next year, I would be signing up the year after. You can always just ditch it. Yeah. 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 Okay. Because what they're trying to do right now is they're trying to make it so that perhaps one AP course and another AP course run in a linear system where we have day 1, day 2, day 1, day 2, maybe with AP chemistry and calculus alternating, so that, because when you take AP courses, the way it's set up, the people who run the exams are in the United States, where school finishes basically beginning of June. Okay, they start in August, but they finish beginning of June. So the exam is on like the first 2 weeks of May. So either you take your AP course from September to January, and then you have 3 months to forget everything, or you have February, March, April, and then your exam is like the 1st of May. So you have 3 months to study. So it's not, semester system is really, really bad for AP, because otherwise you have a full semester, but then you get to forget, or you only have 3/5 of a semester, and then you're writing the exam. So they're looking at possibly making them linear, so you get like more time and more reasonable time. Anyway, that's what the survey's about. They want to know if that's something that's going to work or not. because it really depends on whether things match up. Yeah. Anywho, you guys could now do some of these exercises. Does that sound good? And if you have not done pages 29 to 31, I would like you to start with pages 29 to 31. Okay?
Yep, okay. Current is the rate of flow. Of electrical charge.
Should.
Yeah. If you imagine this probably from yes.
I say grow too. What's the fastest restaurant?
I'll bring you to Greece, bro.
Take the toast.
Yes.
We'll do the performance dance. So,
Oh, you're pretty cute.
Yes. There is additional.
I have that. And I have a Christmas tree.
what stuff are you supposed to do?
Yeah, it's just my Christmas present, non-insurance.
Just do it.
Is that a good thing?
This is like always my heart.
She's gonna say. Well, not that. I can still call you. Yeah. Yeah, she like that.
So slow, right?
Awesome.
Well, right? Cross five. The end of the week, right? You want to get come back on Monday. I guess that's 60 miles. Wait, what do you mean? Yeah.
I'll get you some. Make up with her. There's a lot of room in your body.
How do you know?
You know, the
Yeah, Lord.
you told me, one of the Spanish one talked. He said, yeah, she said, it's Joseph.
Well, see,
No, you go. After she says it.
Oh, that's for. Oh.
I was my she was about school. I completely forgot about it. All of grade 7, she wasn't even. So she wasn't there. She didn't know. And then she went to the water park. Like the podcast meeting. That was just, I don't know, 90% of the time. I did a lot.
Oh, just put it sure. Where I was.
Oh my God.
Wait, you listen or like no one. Like when I have I can't fucking sleep.
This was true.
Try this one. You've got this out of the skin.
Trying to get a buy for tomorrow's game.
How are you guys doing? So, this is coming along nicely. Like this. Okay, stuff actually on the wall, but no big deal.
Oh.
Okay. No worries. All right. And now what we're gonna do down here is you're gonna write given information over it. Quantity equals number of oh, your quantity here.
Oh.
You're gonna use this. Number. Yeah.
Yeah.
Do you
I-
mind if we get our survey? Like,
That's fine.
like hospital?
Yeah.
Thanks.
Yeah. There you go. Yes. Uh-huh. Yeah. So the unknown for the question word. Yeah. and it's- Yeah, so you want the density. Now, which of these symbols stands for density? Yeah, so you're gonna write D equals. Now, if you know you and now you're gonna write the equation that relates. And don't worry, you don't have to know this one, right? Yeah. And then, on the next page, just
because we have put page. We have your given items here for you. We have our unknown. Yeah, so solve means you want to pin your unknown to be on the top. By itself. Is it on the left? That's done. Yes, and substitute your number in your name for it. Yeah. Yeah. Absolutely. Mass. If it's your mass was here. Mass is going on the top. So, M is on the top. So figure this number on the top. Yeah? Does your book have the front page in it? Because I feel like maybe.
It did, yes, it did, yes, actually.
It does?
Yeah, it did.
Okay, okay, I want to make sure it wasn't
Yeah,
missing.
yeah.
Okay, good.
Thank you so much, by
Yeah,
the
no
way.
worries,
Yes.
no worries.
Oh, you're right. Who's most of
If you asked, yeah.
all three of them, Oh, yeah. What's it?
Oh, I'm ahead of the video now. Oh, you are? Wait, we have to do 9 too. Wait, no, 9 isn't in our book. 9 like 9 isn't in our book. No, why is it? Complete page of the 13. Wait, you did 8? How much you done? Nice. I didn't go to 8 for forget.
No worries.
She's cute, but not because, not because.
That doesn't matter.
It's just no. You don't have to know. You don't do that. No, because it's 6 ahead. You don't put that symbol before. Oh, you're just
The number of estimated
Oh, suck it. Hey, come on. Little suck it.
Let me know if you're done.
Guys, go ahead, sit.
Stay through here.
It might be time to go back to class, friends.
Okay, friends, walk in the road.
Damn.
Is it time to pack up? It's 5 minutes left. Oh, art is fun, just like. And she's like, we have like 5 You got the bar up, or I pushed it back out.
I would say 4 then. You better add the DLC.
So I feel like
The stories are so short. You see Red Dead Redemption? I just got bored. I just got bored. I use Red Knight Stephen Moore.
Yeah, I saw it.
It's like Spider-Man. Omni-Man. Lucky Fires.
We're doing it like Since I was ready, you can send me the QR code as well.
Yes, I'll put you on my list.
Like, do you need to like take the test to like get it?
No. They just want like information from people, like, so they're trying to decide which courses to pair up, right? Because they want like, they don't want to offer like chemistry and I don't know, art history if not the same students are taking those, because it would be good if you could have like day 1, day 2 of courses you want to take, both of them, right? And it would be nice if students can plan around that. So I think that's what they're surveying about, is just what people are planning on taking.